Hi guys. So today we're going to be going through lesson 7.4 scientific notation. So this is in your study guide and intervention worksheet. I'm going to be doing some problems on there for you, and then you'll try some today. So go ahead and get that paper out, and we're going to get started. So scientific notation was created in response to scientists started getting these huge numbers. As we started to be able to calculate things, obviously, you don't want to write something with 20 million zeros. So there's this thing called scientific notation, which gives you the chance to write shorthand a number without having to write a ton and ton of zeros. So if we want to write something in scientific notation, we always multiply by a unit of 1. And when you do this, you always want whatever you multiply, or sorry, not a unit of 1, a unit of 10, I should say. Whenever you want to do that, you always want one number in front of the decimal. So what you're going to do is this. You're going to add a decimal, wherever your decimal is. If it's a big number, you're going to go to the left to make it smaller. You're going to count how many times you move the decimal. So there's 1, 2, 3, 4, 5, 6. I stop when there is only one number in front of the decimal. So this gets me to 5.1, and now I don't have to write all those zeros. So we have 5.1, and then what we're going to write next is times 10 to the power 6. Maybe wondering, where did I get the 6? The 6 actually comes from how many times I moved the decimal. So 1, 2, 3, 4, 5, 6. I moved it 6 times. So this is, 10 to the power 6 is like 5.1 times 1 with 6 zeros, like so. But that is a lot of work, so we don't do that. We don't want to have to, mathematicians are lazy in the fact that we want as many shortcuts as possible. So that is your final answer for problems like that. I'm going to do one more and then you'll try one. So here, again, if there's no decimal, it's right at the end. Any whole number has a decimal at the end of it. So we count 1, 2, 3, 4. Hopefully you're following along with your paper. 5, 6, 7, 8, 9, 10. Again, we want one number in front of the decimal. So then I have 8 point, because that's where I put the decimal, 0, 3. I stop when there's no more other numbers other than 0. And then it's always going to be times 10 to the power whatever we did, however many we moved the decimal. So in this case, it's 10 to the power 10. And that is it. That's all you have to do for these problems. So that's when you're going from a big number to a small number. In science, a lot of times when you're talking about microscopes, you might have a really tiny number. And in that case, that's where we do problems like 7, 8, and 9. Pause this video, try the ones with the big numbers first, since it's fresh in your mind. Try those first, and then we're going to go to this. So in this one, we want to go from standard form to, I guess I didn't add any of the smaller ones. If it was a smaller one, I guess I could add it in here. If you had a smaller number, basically what you're going to do is move the opposite way. So if I had 0.000 something, 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 you would go the opposite way to move it to be a big number, or to make it, to be a whole number. And then you would just say to a negative power. So that'd be 10 to the power negative 3 if I was trying to make it bigger. So for example, something like 0.000002020, since that's our year that we've been dealing with. Forgot a 2. I want to make this into scientific notation. So I want one number in front of the decimal. So I'm going to count 1, 2, 3, 4, 5. I moved it 5 times. So then I have 2.020 times 10. It's always going to be times 10 to the power something. And I moved it 1, 2, 3, 4, 5 times. But because it's small, it's going to be a negative exponent. And that's how you'll do those. So pause it, try those problems, then we're going to move on. The other thing you're going to be able to do is switch from standard form, which is whole numbers, to I'm distracted by Einstein in my background, to be honest and transparent with you. That's really funny. He's just kind of peeking over, creeping a little bit. You're going to switch from standard form to scientific notation and scientific notation back to standard form, which is just regular numbers. So this one is in scientific notation. The first thing you need to look at is this exponent. If it is a positive positive exponent, it's going to be a big number. If it's a negative exponent, it's going to be a really small number. So that's what to keep in mind when you're figuring out which way to move your decimal. So the first thing you're going to do is you're going to rewrite your decimal part below. Then in this case, it says 10 to the power 4. So I'm going to move it 4 times. Now, when you're trying to figure out which way to go, either to the right or to the left, I want to make it bigger, so I know I'm going to have to add some zeros. So I'm going to go to the right. So I'm going to count 1, 2, 3, 4. Now, there are no numbers here, so all you have to do is fill in the little loops, the little spoons with zeros. And now your decimal is at the end. So you have 4, 9, 1, 0, 0, or 49,100. And that's your answer. If there's a negative, you're going to actually make this number smaller. Again, so copy your number that's not the scientific notation part of it. And instead of making the number bigger to the right, you're going to make it smaller. So you're going to count 1, 2, 3, 4, 5. Every time there's an empty spoon, you're going to add a 0. This is looking very ugly, but that's all right. And that's where your decimal is going to go. You're just moving your decimal 5 times. That's what that notation is saying, basically. So you're going to say 0 point. Then I have 4 zeros. 1, 2, 3, 4. Then a 3 and a 2. And that is a very, very small number. And that's what you have. So try the rest of the problems like that. Pause me and then join back. The next thing you're going to do is when you are evaluating products. So that's when you're multiplying. So what you're going to do here is you're going to take your 3.4 and your 5, so your regular numbers, and you're going to multiply them first. You are more than welcome to use a calculator. I'm going to do that right now. And that is 17. Now, think back to our work on exponents. And when you're talking about exponents, when you're multiplying them, you add up your exponents. So now you have 17 times 10 to the power 3 plus 4, which gets us to 7. The problem here is that there is not only one number in front of the decimal. So I need to move it once more. This is even bigger, so we're going to actually add a number to our 10 to the power 7. 1 bigger than 7 is 8. Think about it. If it's bigger, if it's too big, you make the number bigger. If it's too small, you make the number smaller. And that's it. That's all you have to do for that one. For 14, I'm going to try that one with you as well. Again, you're going to combine your 2.8 and your 1.9 first. You're going to multiply them. 1.9 times 2.8 in your calculator, and it is 5.32. You can do a little bit of a happy dance because we don't even have to fix this one because there's only one number in front of the variable. Times 10 to the power, I need to add up the exponents. I have a minus 4 and a 7. 7 minus 4, that's simple enough, 3. And that's all you have to do for that problem. Pause me if there's more problems like this. Yep, pause me and try the others. If you need to copy this down, pause it here. I'm going to keep moving forward. The last type of problems is with division. Now, I will remind you in the rules of exponents, when you multiply, you add them up. When you divide, you're going to subtract. So just keep that in mind first. So the first thing I'm going to do is I'm going to deal with these numbers, the regular ones that are just kind of hanging out here. The 4.9, if I can type in my calculator, divided by 2.5. And that becomes 1.96. We can do a happy dance because, again, there's only one number in front of the decimal, so that's fine. Then we have -3, but then we need to subtract -4. The interesting thing with this is minus a negative actually becomes a big old positive. So -3 plus 4 actually ends up being just 10 to the power 1. So as to express the result in both scientific notation and standard form, so I know 10 to the power 1, I'll just move it once over. So standard form would be 19.6. I just made a real complicated number into a very simple number. Same thing for 18. In your calculator, you can do 5.8 divided by 5, and that is 1.16 times 10 to the power, again, you're going to take the top number, which is 4, and subtract the bottom number, which is -2. Minus a negative again becomes positive, and it becomes 10 to the power 6. The last part of this is making it into standard form, so we're going to move this 1.16, going to move the decimal 6 times. Because it's a positive, you know it's going to be a big number. So you're going to count 1, 2, 3, 4, 5, 6. Every empty little loopy spoon thing, we're going to add a 0. That's a scientific word, obviously, loopy spoon thing. But so you'll just add zeros, and your decimals at the end here now. So you have 1, 1, 6, 4 zeros, 2, 3, 4. Then you could add your commas every 3. So it's 1,160,000. And those are your answers. Thank you for taking the time to watch this video, especially before coming to me with questions. It's funny how many times people come to me and want me to teach before even watching this. So thank you for taking the time to do that. I am proud of every single one of you guys. You guys are awesome. I miss having you guys in class. I hope I can see you guys soon. This won't last for forever, so I appreciate you watching this. All right, see you guys.